Hi and welcome. In this video, we're going to go through some written examples that involve function transformations. So specifically, what I'd like us to do is to be able to explain the transformations that we see in words and write them in the order that they are applied. So we want to know how to describe the transformation, and we want to know which order they're supposed to happen in. So I'll do a little review first before we try the examples. So I'm going to put on the screen the way that I typically summarize all of the transformations together. This focuses specifically on the scaling and the shifting transformations. The reflections occur with negatives happening in either the A or the B position. Those ones I feel like are a little easier to see since you'll just notice a negative, but there are more details with the other types of transformations. So we have a vertical scaling by A on the outside, then a horizontal scaling by 1 over B on the inside, a horizontal shift by plus or minus C. If it's a plus C, it's to the left, and if it's a minus C, it's to the right. And then we have a plus or minus D on the outside. So if it's a plus D, it's a shift up, and if it's a minus D, it's a shift down. So this is a review from the other video where we went through how each of these transformations work, but this is just the way I typically write this to kind of help me remember where everything's occurring. Okay, now for the order. So our main rule of thumb is that we're going to do the inputs and then the outputs. So the input transformations occur first and then the outputs. Also, if you're really not sure or you forget, you can just try to follow order of operations. For me, that means starting on the inside and working my way out. So for us, if we look at the inputs, our options are B and C. C is in parentheses on the inside, and so this is going to be my first transformation. So first, I'm going to do a shift left or right, and that's my first transformation I apply if there is one. Next, I'll do a horizontal stretch or compression. So we do that one second if there is one of those. All right, now we move to outputs, and here we follow order of operations. So we do the multiplying first, and then we would do the adding or subtracting. So we would do the vertical scalings, which are the stretch or compressions. Then we would finish off the transformations by doing any vertical shifting up or down. So that would be how we would end it. And of course, if there aren't any compressions or stretches to do or any reflections, we just jump to the shifting up and down. So that's the order we always do these things in. And within steps 2 and 3, we also do reflections. If there was a negative in the position of B, this would be a reflection over the y-axis since it's a horizontal reflection. If there was a negative in the A position, this corresponds to a reflection that happens vertically, which means it happens over the x-axis. You can do the little parts in whatever order you want. So if you have both a reflection and a scaling, you can pick the order. You just need to do the horizontal ones first and then the vertical ones. All right, so what I'm going to do is just write us out some transformations that have been applied to a function. Then we want to write which order they occur in and explain them in words. So there are multiple ways to do the explanations. I'm just going to write them in the way that makes sense to me and the language that I have used in these videos. But of course, if yours is slightly different, that is definitely okay, as long as you're able to communicate what you are meaning. So the functions we're going to look at are negative f of x plus 2, all minus 3, then 9g of x minus 1, then k of negative 2/3 x, and lastly, 3/5 h of 2 times x minus 5, all plus 1. So these are the functions. We're going to write out the transformations that are happening and put them in the correct order. So I'll just do these one at a time. If you want, you could stop now and try this out, but no worries, we can also just jump right into it. Okay, so looking at my first function, I have negative f of x plus 2 minus 3. So I want to start with my inputs. I'm looking at what happens to the x values that are inputs to the function. Here I'm seeing we have this x plus 2. That plus 2 corresponds to a shift left by 2. So remember, the input transformations are kind of opposite of what you would think, so that plus 2 is a shift left. All right, that's it for the input transformations. Now we're on to the output transformations. So next I'm looking at the multiplication that happens on the outside to the f, and here I see we have a negative. So this negative tells me that we have a reflection, and since it's happening to the outputs of the function, this is a vertical reflection. To write this down, I would say that we reflect over the x-axis. So remember, if we are reflecting, everything on the top of the x-axis is going down to the bottom, and vice versa. A reflection over the x-axis is a vertical reflection. All right, then we just have one more transformation that happens with the outputs of the function. This is the -3 at the very end. So we're taking the outputs and we're subtracting 3. This corresponds to a shift down by 3. And there we go. We have 3 transformations, and this is the order they occur in. Next, let's look at 9g of x minus 1. So remember, again, we start with the inputs of the function. So this is what's happening to the x values. We have this -1 on the inside of the function g, and so this corresponds to a shift right by 1. Again, those input transformations are kind of doing the opposite, so the -1 actually shifts the graph to the right by 1. That's all of the input transformations, so now we move to the outputs. We have this 9 being multiplied by my outputs, being multiplied by my g of x minus 1, and so this corresponds to some sort of vertical scaling. Specifically, 9 is larger than 1, so we're doing a stretch. We're doing a vertical stretch by a factor of 9. This means all of the outputs are being multiplied by 9, so I really like to write that by a factor of 9, just to indicate that. So we have 2 transformations here, we shift right by 1, and then we do a vertical stretch by a factor of 9. All right, we've done 2 of the examples, let's do the last 2 now. So we're going to look at k of -2/3 x. So we start with our input transformations. I think all of our transformations are on the inputs here, since we just have this -2/3 being multiplied by the x. So first, the negative corresponds to a reflection. So it's taking all of the x values and changing their sign. So this is a reflection over the y-axis. The horizontal reflection occurs over the y-axis. Then we also have this 2/3. So this corresponds to some sort of horizontal scaling. Specifically, 2/3 is between 0 and 1. It's less than 1. And so this is a horizontal stretch. It's a horizontal stretch by a factor of 1 over b, and here our b value is 2/3. So 1 over 2/3. Then when we simplify this as a fraction, this is equal to 3/2. So we're doing a horizontal stretch by a factor of 3/2. And these are our 2 transformations. So in terms of order here, we can actually do these in any order we'd like. They're both just being multiplied by that input, the x, and so we can do the reflection first and then the stretch, or we can do the stretch first and then the reflection. The order here does not matter because these are our only transformations that are happening. All right, we're on to our last function. Here we have 3/5 h of 2 times x minus 5 plus 1. So we work from the inside and work our way out, starting with the inputs. So I'm going to look at that -5 first. That -5 is going to correspond to a horizontal shift, which goes right by 5. So that's our first transformation. Then we have the 2, which is being multiplied by the resulting input. So 2 times x minus 5 is a horizontal stretch or shrink. So here I say we have a horizontal shrinking or compression, and it occurs by a factor of 1 over 2. So again, we're in that case where 2 is larger than 1, and so this is going to be a compression that happens horizontally, and it happens by a factor of 1 over b, which is 1 over 2 in this case. So those are our input transformations, and they happen in this order. All right, now we move to the outputs. So we start with the number that's being multiplied, so that 3/5. This is a number between 0 and 1, and for the vertical transformations, this is going to be a vertical compression or shrinking. So this is a vertical shrink by a factor of 3/5, which means all of the output values get multiplied by 3 over 5, effectively shrinking the graph vertically. Okay, we're almost there. Now we just have our final transformation. This is the +1 at the very end, and this corresponds to a shift vertically up by 1. And there we go. Those are our transformations. So even though there's a lot going on here, we always do them in the same order, starting on the inside and working our way out, which means we always do the inputs first and then the outputs. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.